In this video, we'll explore the moisture sensor, dive into how it works, and learn how to effectively integrate it into our projects. A typical moisture sensor consists of two metal prongs that are inserted into the soil to detect moisture levels and two pins for transmitting electrical signals. These sensors typically include an LM393 chip, which converts the analog signal to digital and stabilizes the output. Additionally, the built-in potentiometer allows us to set the reference voltage, enabling precise adjustment of the moisture level threshold. There are two types of moisture sensors: resistance-based sensors and capacitance-based sensors. The capacitance-based sensors use the dielectric property of soil, which changes with moisture, to measure the capacitance of a circuit. On the other hand, resistance-based sensors measure the resistance between two probes. Wet soil conducts electricity better than dry soil, so resistance decreases with more moisture. Now let's explore how we can integrate this sensor into our projects. For this project, all we need are some jumper wires and LEDs to visually indicate the moisture level in the soil. Also, any type of microcontroller will work for this project, but I'll be using an Arduino Uno. First, let's connect the moisture sensor to the microcontroller and start measuring some values. Connect the two pins of the sensor to the LM393 chip. The LM393 chip has 4 pins, 2 for VCC and GND, and the other 2 for digital and analog signal outputs. For this project, we'll use the analog pin of the sensor and connect it to any of the analog pins on the Arduino. Additionally, we need to connect the VCC pin of the sensor to the 5V pin on the Arduino and the GND pin to the ground. Now that the sensor is set up, let's write the code to receive and read the moisture data. First, we need to define a variable for the analog pin we're going to use, as well as another variable to store the values received from the analog pin. Then in our setup method, we need to initialize the serial communication. Next, in the main loop, we will use the analog read function to capture the signal and store the values in our variable. Finally, we will print the received values to the serial monitor. At the end of the program, we need to add a small delay to ensure stable readings and prevent excessive serial output. Now let's upload the code and see the results. We can observe that the value reads 1023 when no moisture is detected. However, if we touch the sensor, the value changes slightly due to the moisture from our fingers. Now let's insert the sensor into the soil to observe the values it receives in different moisture conditions. Now let's add the LEDs so we can visually display the moisture value based on the sensor readings. I'll use the GND rail of the breadboard to create a single universal ground connection and use pins 8, 9, and 10 on the Arduino to send signals to the LEDs. Now we need to add some additional code to the previous one to send signals to the LEDs based on different moisture levels. First thing first, we will add 3 variables for 3 new pins that we are using for LEDs. Then we need to define and initialize these pins as output. In the main loop, we will use the value read from the analog pin to determine which LED should be turned on. For example, if the value is between 800 and 1023, it indicates very low soil moisture, so the red LED should light up. We also consider values between 350 and 800 as indicating normal moisture levels, while values below 350 represent optimal moisture conditions. After uploading the code, we can observe the results and see how the LEDs respond to different moisture levels. We can observe that when the soil has a medium moisture level, the yellow LED lights up. And as we take it out, we see the value reaches more than 800 and red LED comes on. Now if we add some water, the moisture value drops below 350 and the green LED lights up. You can use this logic to create a smart watering system for your plants. Simply add a water pump and include some additional code to control it based on soil moisture levels. If you enjoyed this video, please like it and subscribe to our channel for more helpful and exciting content.